Hi guys, welcome back to lesson 9.3, rewriting radical expressions. So we have 5 new vocab words today. One big part of 9.3 is perfect squares. So you guys know those are numbers where we take 1 and we square it, 2 and we square it, 3. We can take all of these whole numbers and square them, and that's where we get the perfect squares from. We are going to want to have those at the forefront of our minds today. We are going to be using perfect squares in every question. We're also going to see a lot of these square root symbols. We also call it a radical, an expression that we might see. A lot of our questions are going to look something like this, where we have numbers and variables as our radicand on the inside of the radical. And then lastly, we have this property we're going to use where essentially if we have 2 radicals, 2 square roots, we can multiply everything on the outside together. And we can multiply everything on the inside together. And then today we're going to learn how to simplify. All right, we're going to skip example 1 for now and jump into example 2. All right, it says what is an equivalent expression for the square root of 63? Now, by all means, we could all go in our calculator, click the second button, x squared, and type in 63, that would tell us approximately what this number is. If I try that really quick, the square root of 63 in my calculator is about 7.9372, and it kind of keeps going forever. So we actually don't want to do that. That is not wrong to do that, but we want to see just today how we can simplify, how we can take a radical and keep it as a radical without making it into this crazy decimal. So here's how we're going to do it. We are going to try to pull out perfect squares, is what we call it. We're going to try to break down the numbers that are inside of our radical. We call it the radicand. We want to break down those numbers into perfect squares. So we're starting with the number 63. In my brain, I'm going to do like a little brain bubble off to the side here. I'm going through all of my perfect squares. So 1, 4, 9, 16, 25, and so on. I want to find a perfect square that multiplies into 63. So one of these numbers times another number can equal 63. Now, first thing that came to mind, I kind of went through, 1 and 4, those were not working, but I can divide 63 by 9. And how I can do that is I can break it up into 9 times 7. 9 times 7 is equivalent to 63. Here's why this is helpful. This is a perfect square. Essentially, what we're doing is we are replacing the square root of 63 with the square root of 9 times the square root of 7. And what that allows me to do is take the square root of my perfect square. The square root of 9 is 3. The square root of 7, we cannot simplify. That is not a perfect square, so it just stays exactly how it is. Essentially, we break down 63, we look for a perfect square, we take the square root of it, and we bring it out front. And this is our final simplified answer. If I now type this in my calculator, we're still ending up with the same 7.92 number we got earlier. This is just a more simplified version, and that is all we're doing in lesson 9.3. Let's try a few more. If you want to pause and try these on your own, go for it. If you're feeling a little stuck, let's do a few more together. I want to break down the square root of 44 into 2 numbers that multiply together, where at least one of them is a perfect square. So in my mind, I'm going through some options, 4, 9, 16. You can even try these in your calculator. I want to know which perfect square goes into 44. And it looks like 4 is going to be our winner. 4 times something does equal 44. So I'm going to break 44 down into 4 times 11 because those are equivalent. And now I'm going to write this a little bit different than before. I'm going to draw an arrow to the front of my radical that brings my perfect square out front. And when I bring a number out front, we take the square root of it. So the square root of 4 is 2. Square root of 11, we cannot do. 11 is not a perfect square, so it just stays on the inside. And sometimes we could keep going, but 11 I cannot break down any further into any other perfect squares, so we're done. That's our final answer. We could double check in our calculator, type this in and this, just to make sure we got this answer right. We should still be getting the same exact decimal. All right, let's try one more over here. So I already have a number out front. That is awesome. That's not going to change anything about our process. That just means that whatever number we are going to pull out from the inside, we're going to times it by that 3 that's already there. All right, so let's go ahead and try it. 27. First number that came to my mind was 9. 9 is one of our lovely perfect squares, and we know that 9 times 3 is 27. So we wanted to break this down because we need a perfect square. And then I can pull that perfect square out front. And since there's already a 3 there, we're going to multiply those. So the square root of 9 is 3. So I'm going to times 3 by another 3 to get 9 out front. So quick recap, we took the square root of this, which was 3, and we times it by the 3 that was already out front. And then this guy right here is not a perfect square, so it's going to stay on the inside, just square root of 3. That is our final answer. All right, let's check out example 3, where now we have some variables. How are we going to deal with that? Here's our rule of thumb. I want you to go ahead and write down this rule right next to example 3. This is our rule for variables. Every 2 x's that we have, we can take the square root of to get 1x. So for example, if we have x 10 and we need to take the square root of that, we could take out 5 x's. So essentially we're taking the even exponent and we're dividing it by 2. Let's go ahead and try that in the first example. Now, we're still going to break down 63, just like we did before. We want to break that down into perfect squares, which before we saw was 9 and 7. All right, when we break that down, I'm going to bring down my square root. And we pull out our perfect square. Here is what we're left with. 3 we can pull out front, because that's the square root of 9. 7 stays on the inside. And we haven't done anything with x to the 9 yet. All right, so how we're going to deal with our variables. I'm going to give you 2 options. What I like to do is I like to break down all of the variables into as many x squareds as I can. So what I mean by that is I'm going to make a really long radical here. And x9, I'm going to break down into as many x squareds as I can. Let me erase this for a second. All right. So what I'm writing right now is the same thing as x to the 9. Remember, when we multiply variables with the same base, we add their exponents. So this is 2, 4, 6, 8, 9. I just expanded, but this is equivalent to x9. And why I like this is because we know that every x squared that's on the inside of a radical, when I take the square root of it, we can take out 1x for each of those. So how many x's can I take out in total? We can take out 4. So for every x squared, we can take out 4 x's out front. So 4x is being brought to the front of the radical, we can write as x to the 4th. We just squish that up against the 3 that's already out there. And there's 2 things that we did not pull out from under the radical. That was the 7 and the x1. So those, just like before, are going to stay on the inside. And that right there is our final simplified answer. All right, let's try another one. This right here is a gift, you guys. When we have a perfect square already, we would only break this down into another perfect square. So if we already have a perfect square, we just need to take the square root of that. And we all know the square root of 25 is 5. So we pull the 5 out front. And there's nothing left on the inside, number-wise, because that was a perfect square. So now we just have to break down x3. All right, with any variables, I'm going to break it down into as many x squareds as I can. So what I have on the screen now is equivalent to x3. If I add my exponents 2 and 1, that is where we get the 3 from. And every x squared, when I take the square root of that, we can pull out 1x. So we bring an x out front to join the 5, and this 1x is going to stay on the inside. So when we simplify, we bring out 1x, we leave 1x on the inside, and that's our final answer for part A. All right, one more over here, part B. Again, you guys, we have a perfect square. Notice how I always start with the numbers on the inside of our radical. I think that's typically the easiest. Just focus on the numbers first. So 4, the square root of 4 is just 2. There's no number that's going to be left on the inside of the radical. So we just need to pull out the square root of 4, which is 2. Since there's already a number out front, remember we always multiply those. So now a 5 and a 2 out front is going to make 10 because we multiply them. And I am not left with any numbers on the inside except for x to the 17th. Now, by all means, I could totally list out all my x squareds again. Or here's kind of the other rule. We really just want to make an even exponent. If we have an even exponent, then we can take out half of what we see. So for example, I'm just going to rewrite this as x to the 16th. I'm going to go down 1 times x to the 1. Would you guys agree that that is still the same thing as x to the 17th? Yeah, it is. Just because when I add my exponents, we get back to 17. And why this is helpful is it's still the same process. Every x squared, we can take out 1x. And so from x to the 16th, we can essentially take out 8 x's. So that is still taking the square root. We bring the x to the 8 out front. And the only thing left on the inside is the 1x that was left over. There we go. So the numbers, we take out perfect squares. For exponents, here's our little rule. We're going to take it up just one more notch today, and then we'll get some practice in class. So our last notch that we're going to take it up is we know how to work with numbers and variables now, but what if we have 2 expressions and we multiply them? Here's essentially the rule. I will say the order actually doesn't matter. The order is up to you to decide which makes most sense. I personally like to multiply first and then simplify. This is the order I like to move in, but theoretically you could simplify first and then multiply. Sometimes, though, you'll have to simplify again. So I'll show you how I do it in the least amount of steps possible. All right, step 1, we're going to multiply. And with radicals, the rule is that we can only times things that are on the outside together and times the things that are on the inside together. So we'll start with the outside. 3 times 2 is 6. And on the inside, I'm going to start by timesing the 5 and the 15. 5 times 15 is 75. And then when I multiply the x's that are on the inside, we add the exponents to get x to the 4th. All right, now we just got to work on simplifying. That was step 1 to multiply. Step 2, we can simplify just like we did in example 3. All right, 75. How can I break that down into perfect squares? 75 is not a perfect square itself, so I'm in my mind going through our perfect square options. Does 4 go into 75? 9, 16, 25. 25 stands out to me because I know 75 is 3/4. So 25 times 3 is equivalent to 75. And why this is helpful is 25 is one of our perfect squares. If I'm going to pull that out front, I need to take the square root of it. When I take the square root of 25, I get 5. Since there's already a number out front, I'm going to multiply 5 by that 6. And what that leaves me with now is 30 out front. We haven't done anything with x to the 4th yet, so that will stay. And the 3 was not a perfect square, so that will stay on the inside as well. The 3 is left over and x to the 4th. All right, this number cannot be broken down any further. That's when we move on to our variables. We can break this down into as many x squareds as we can, or as long as we have an even number exponent, we just want to divide that by 2. That means that I should be able to take out 2 x's, x squared. And when I do that, we join it with the 30. The 3 is left on the inside, and I am left with no x's on the inside of my radical. Another way to visualize this is x 4th is x2 times x2. We can take out 1x here, 1x here, and we're left with nothing. And here's our final answer, final simplified radical. You're welcome to pause and try the next two if you're feeling good. Otherwise, keep following along with me and you can check your answers as we go. All right, I'm going to start by multiplying first, timesing the numbers on the outside. 1/2 times 4 is 2. All right, on the inside, 21 times 7. We get 147. This is going to be a tricky one. 147. And then I multiply our variables, x3 and x2. We add the exponents when we multiply variables with the same base to get x5. All right, let's start with breaking down the number on the inside of my radical. Now, this is really tricky. Off the top of my head, I really don't know what this is. What perfect squares go into 147? So here's what I would do in my calculator. I would try to do 147 divided by 4. That's the first perfect square that I typically like to try. And if I don't get a whole number, then I move on. 4 does not go into 147. All right, let's try dividing by 9. 147 divided by 9, not a whole number. So we keep going along. Let's try 16. 147 divided by 16. Also a decimal. We're looking for a whole number here. Divide by 25. Still not a whole number. All right, I don't think we've used any perfect squares higher than 25 today, so let's keep going. 25 is 5 squared. The next perfect square we could try is 36. Still not a whole number. Whew. All right, let's keep going. 7 squared is 49. 147 divided by 49. Guys, here's our winner. So when we do 147 divided by 49, I got a whole number. I got 3. What that means is that 49 is a perfect square that goes into 147. Let's break it down. So 147 is the same thing as 49 times 3. We take our perfect square, we take the square root of it, which is 7, and we pull it out front. When we pull numbers out front, we multiply them. 7 times 2 is 14. So what's going to stay on the inside? That 3 we did not pull out front because it's not a perfect square. And we haven't done anything with our variables yet. So let's go ahead and pull those down as well. All right, last step today. We are going to break down x5 into as many x squareds as we can. So here's what we're looking at. X squared times times x1. That is equivalent to x5, right? If I add all those exponents, it's still the same thing as x5. And every x squared, I can take out 1x. So how many x's in total can I pull out? We can take out 2. So 14 was already out front. 2 x's are going to join it. And on the inside, we're left with the 3 and 1x. 3 and 1x. All right. I lied. We got one more here. Let's go ahead and finish this one here. For our funsies, how about this time? I'm going to try to simplify first and then multiply. I did mention at the beginning that order does not matter. I like to multiply first and then simplify, but it's truly a preference. If you want to try to simplify first and then multiply, you absolutely can. I'm going to try to do that in this question. All right, just focusing here. I'm going to simplify that as much as I can. So I'm going to do this one a little bit quicker. The 12, I can break into a perfect square. I know 4 goes into 12, 4 times 3. And x9, I'm going to break that down right away too, into an even exponent. So x to the 8th times x to the 1, that is the same thing as x to the 9. So what can I pull out? We can pull out this perfect square. I'm going to pull out 2 when I take the square root of 4. When I take the square root of x to the 8, I'm pulling out 4 x's, x to the 4th. So what I now am left with, I'm going to actually write this up top. I'll do this in pink. I'm going to pull out 2 and multiply that by the 2 that's already out front to get 4. And we bring the x to the 4th. And on the inside, Let's see, what am I left with? We are left with the 3 and 1x. 3 and 1x. All right, so that was just the first radical. Now I'm going to go ahead and simplify the square root of 18, x to the 5th. So 18, I can break that down into 9 times 2, and I like to do that because 9 is a perfect square. X to the 5th, I'm going to break that down into x to the 4th times x to the 1. What can I pull out from the square root? I can pull out the square root of 9 and the square root of x to the 4th. And when I do that, I take out 3 and 2 x's. On the inside, I'm still left with the 2 and x to the 1. And that final answer would be this. All right, so we simplified just the two expressions separately, and now we still have to multiply. And hey, we might be able to simplify again at the end. That's kind of the risky part of doing it in this order, but let's see what happens. All right, I'm going to multiply everything that is out front to start. So starting with 4 times 3, we get 12. And then x to the 4th times x to the 2nd, we add those exponents to get x6. All right, now we go under the square root symbol. Same thing, let's start with the numbers. 3 times 2 is 6, and x times x is x squared. This is an awesome answer, but since we simplified first, multiplied second, let's just double check and make sure everything under my radical is fully simplified. Are there any perfect squares that we can break down 6 into? I don't believe there is. 4 does not go into 6, and we can't go any higher. So the 6 is simplified. But we know that every x squared, we can take out 1x. So we can actually pull out one more x here, add it to the exponent we already have, and here is our final answer. 12x to the 7th over 6. That is our final answer, guys. Thanks for following along. We'll get some more practice in class today.